Okay guys, today we're going to do 7.1a, which is area of a region between two different curves. And the other day we did calculating area underneath one curve. For example, if I just gave you the f of x, negative x squared minus 2x plus 6, and I asked you to find me the area underneath f from 1 to 3, you can integrate it and plug in your 3, plug in your 1, and so on. Or if I gave you g of x and asked you to find me the area underneath g of x, you could do that for me, right? Integrate it and then plug in your values. But what if I asked you to find me the area in between f and g? Well, could I figure out what the area of f was, figure out what my area of g is, and then just subtract the two numbers? And that would give me just my area in between my two curves, right? So if I ask you to find me the area in between the two curves, you can find the area of the top function, which is integrating it, find the area of the bottom function, integrating it, and then just subtract those two values. Okay? So to find the area between the two curves, if f and g are continuous in the interval, and f is the function on top is greater than g in that whole interval, then the area between the two curves of f and g from the line x equals a to x equals b, so those are your two limits of integration, is the integral from a to b of f of x minus g of x. So instead of doing two separate integrals, you can do one big one of f minus g. Let's look at an example. Example number 1 says find the area of the region bounded by the graphs of y equals x squared plus 2, y equals negative x, the line x equals 0, and the line x equals 1. Okay? You are not always going to be given a graph. Actually, more times than not, you will not be given a graph. Okay? So what you might want to do first is kind of visualize what's going on. So what would the line, what would the graph of y equals x squared plus 2 look like? Well, we know an x squared graph is a parabola. If there's a plus 2 in the back, we know it's kind of moved up on the y-axis too. So our parabola graph would look something kind of like this. Yes, I know I gave you the picture, but if I didn't give you the picture, could you visualize what's going on? Okay. The next equation they give us is y equals negative x. There is no squared, so it's not going to be a parabola anymore. This looks more like a y equals mx plus b, like a line, with a y-intercept of 0 and a slope of negative 1. So the graph of that equation would look something like this, right? We also need to visualize the last two lines. The one x equals 0 means I'm at x at 0, and I have a vertical line like this. And I have the line x equals 1, so I'm touching x at 1, and I have a vertical line like that. So the area that I'm looking for is this area in between, okay, that little shaded area inside there. So let's integrate. Because we're finding the area between two curves, let's integrate it. And we're integrating it from where to where on the x? Well, from 0 to 1, right? Those are my limits of integration. We're integrating it from 0 to 1. All right, who is my top function? The one that's bigger than, above. It's my x squared plus 2, right? Minus, what's my lower function? Negative x, you see those two negatives? I'm subtracting a negative, so eventually what's that going to turn into? Positive, right? So to find the area between those two curves, I'm going to integrate my function x squared x squared plus 2 plus x from 0 to 1. What if they didn't give me a picture? And what if I couldn't necessarily visualize who was greater than, who was above? How could I figure out who was above between 0 and 1 if I don't have a picture? Could I plug a value in? Could I plug like I don't know, 1/2 in? If I plug in a 1/2 for both of those equations, if I plug in a 1/2 to this equation and I plug in a 1/2 to this equation, which one would be greater than? Well, the one that would be greater than would be my top function, if you want to think of it that way. Okay, does that make sense? All right, so if I'm integrating this, I'm integrating x squared plus 2 plus x dx. So I have an x cubed over 3, I have a plus 2x, and I have a plus x squared over 2, and I'm integrating it from 0 to 1. If I use my fundamental theorem of calculus and plug in my 1, I have a 1/3 plus 2 plus 1/2 minus 0, 0, 0, minus 0, right? You okay with that? All right, getting a common denominator here with all my different fractions. I have 2/6, I have 12/6, and I have 3/6. So adding them all together, the area in between those curves from 0 to 1 is 17 over 6. Okay, let's do a harder one. In example number 1, the graphs didn't intersect, right? And the values of a and b were given to us. They gave us x equals 0 and x equals 1, so we knew we had to integrate it from there to there. What happens if we make it a little bit harder on us? So look at example number 2. Example number 2 says find the area of the region bounded by the graphs of f of x, if f of x is 2 minus x squared, and g of x, if g of x is x. Okay? So pretend like they didn't give us a graph, because again, they're not going to always give us a graph. They're probably not going to give us a graph. This first graph, f of x, we know is a parabola. It's an x squared. There's a negative in front of the x squared, so I know it's a parabola. It opens down. It opens down, but there's a plus 2 in the front here, so I know it's moved up 2. So if this were my x and y, I know I'm up to 2, and I'm a parabola that kind of looks like this. Okay, if they didn't give us a picture, could we visualize? My second equation is y equals x. That's a line with a y-intercept of 0 with a slope of positive 1, up 1, over 1, and so the line kind of looks like this. So on my example number 1, they didn't give us, or they gave us x values, x equals 0 and x equals 1. On this one, they don't. But could we still find the area in between those two graphs? If we're looking for the area in between these two graphs, it's from where to where? It's where they intersect, right? It's from here to about here. If we look at the graph, because they gave us one, what are those x values? Looks like it's from -2 to +1, right? But again, they're not always going to give us a graph. So if we weren't given a graph, how could we still, algebraically, by hand, without graphing it, how could we figure out my limits of integration? Well, isn't it where f of x and g of x intersect? Or if you think about a system of equations, right? It's where they equal each other. So where y equals 2 minus x squared and y equals x equal each other. So can I do a system of equations and set them equal to each other? And figure out what x equals? If I have this equation, 2 minus x squared equals x, the only way that I can solve it, it's a quadratic, is by trying to factor. Hopefully it factors. I'm going to go ahead and move my x squared over next to my x. I'm going to move my 2 over, and let's factor it and see if we can get an x value. All right, what numbers multiply to -2 that when you add them together you get +1? Does that work? +2, -1? So that means x equals -2 and x equals +1. So what does that mean about my two graphs? It means that my two graphs intersect at -2, at x equals -2, and x equals +1. Isn't that what we said when we looked at the actual graph? Okay, so if they don't give us a graph, we can tell where their intersection points are, again, by setting them equal to each other, doing a system of equations and figuring out where they intersect. Okay, so I know now that my limits of integration are going to be from -2 to +1. If they didn't give us a graph, could we figure out which function was my top function and which one was my bottom function? Because I need to do top minus bottom. Okay, So if I'm in between negative 2 and 1, what number is in between negative 2 and 1 that I can test? What's the easiest number in between negative 2 and 1 that I can test? Can I test 0? So what was f of x? F of x was 2 minus x squared. G of x was x. So if I plug in a 0 into my f of x, what do I get? 2? If I plug in a 0 to my g of x, what do I get? 0? So which one's greater than in that interval? F, right? So that means in the interval from negative 2 to 1, no matter what number you pick, f should always be above g. So when I go to find the area in between my two curves, I'm integrating from where to where? Negative 2 to 1, right? Of my top function, which was f, 2 minus x squared minus g. Okay. All right, let's integrate it. The integral of 2 is 2x, x cubed over 3, x squared over 2, and I'm integrating it from negative 2 to 1. Plug in my 1, and I get 2 minus 1/3 minus 1/2. Minus, if I plug in negative 2, what does that give me? Negative 4. If I plug in a negative 2 cubed, negative 2 cubed is back to a negative 8, but there's a negative that's already in front, so can I say positive 8/3? Right? Negative 2 cubed is negative 8 with a negative in front makes a positive 8/3. Plug in a negative 2, negative 2 squared is positive 4 with a negative in front, so can I say negative 2? All right, will you simplify that for me, please? Will you get a common denominator and combine like terms, and let me see what you get for your area in between f and g. Alright, when you combine those, you get a common denominator. You should get 27 over 6. That can be reduced to 9 halves, 9 over 2. So that is the area underneath the two curves. Now it should be positive. And why is my answer, what does it mean for my answer to be positive? Right, it was a positive 9 halves. What that means is that more of your area is above your x-axis than below your x-axis. So isn't that true on our graph? That more of it is above than below? So you should always make sure that your answer makes sense. If you get a negative number, does that make sense? Is more of your stuff underneath your x-axis than above? Okay? All right. Let's do another one. Let's do a trig one. Here's our last example. Example number 2b. It says the sine and the cosine curves intersect infinitely many times. If I were to keep going with my sine and my cosine, they intersect a whole bunch of times. Found in regions of equal area, right? So every time they intersect, the areas in between the intersections should be equal. So if you look at the picture, find the area of one of these regions. Okay, so I want to find the area in between the two curves. So I need limits of integration. So I need to figure out first where my sine and my cosine graphs intersect. So how am I going to figure out where sine and cosine intersect? Well, like on the last example, we're going to take our sine and our cosine and we're going to set them equal to each other. So can I do that? Sine of x equals cosine of x. And now I need to solve. Okay, this one's a little bit tricky at first, but once you see what I do here, it'll make sense. I'm going to go ahead and get this cosine over by this sine. And I'm going to get it over there by dividing both sides by cosine. When I do that, what is cosine divided by cosine? Isn't it just a 1? Well, what is sine divided by cosine? Tangent? So now we have tangent of x equals 1. So now I need to figure out what x equals. using my unit circle, I need to figure out where tangent equals 1. So where, on your unit circle, does tangent equal 1? You should get at first pi over 4, but doesn't it also equal 1 at 5 pi over 4? And couldn't I keep going and going and going around my unit circle a million times? Infinite amount of times? I don't need to find all of the intersections because they're going to intersect infinitely many times. I just need to find the first two. I need to figure out here and here, which we just found was at pi over 4 and 5 pi over 4. So if I can integrate, if I can find the area in between the two curves from pi over 4 to 5 pi over 4, then isn't the area in between the two curves the same all the time because they're symmetric all the way through? Okay, so I'm going to integrate now. Those are my limits of integration from pi over 4 to 5 pi over 4. But now I need to figure out who's the bigger function in that interval. Okay, so in that interval, pi over 4 to 5 pi over 4, if we try to plug in values, think of your unit circle, who's going to be the greater value, sine or cosine? So test the value. I don't know, test pi over 2 if you wanted to. What's sine of pi over 2? Isn't it 1? What's cosine of pi over 2? Isn't it 0? So who's greater in that interval? Isn't it sine? So if I want to find the area in between sine and cosine from pi over 4 to 5 pi over 4, let's integrate. Pi over 4 to 5 pi over 4. My top function, which we said was sine, minus my bottom function, which we said was cosine. There's my sine. Okay? So here we go. What's the integral of sine? Negative cosine, right? What is the integral of negative sine? Negative cosine. Negative sine, right? And we're integrating it from pi over 4 to 5 pi over 4. All right, here we go. So I have negative cosine of 5 pi over 4 minus sine of 5 pi over 4 minus negative cosine of pi over 4 minus sine of pi over 4. Okay? Using exact values from your unit circle, could you evaluate this for me, please? Negative rad 2 over 2 plus rad 2 over 2. Doesn't that go away? Doesn't that give me 0 right there? Right? Inside here, I have a negative 1 rad 2 minus another 1 rad 2. Isn't that a negative 2 rad 2? All over the common denominator of 2. Don't forget about this negative that was in the front at the beginning. So doesn't that turn into a positive? Did I do that right, or did I mess up? Oh, I messed up on my double negatives, didn't I, right here? I have a negative, I was supposed to plug in another negative, that's a positive. I have a negative, I plug in a... This is my fault. Reverse. Negative, plug in another negative. So then these two make a positive. That's a 1 rad 2 plus a 1 rad 2, that's a 2 rad 2 over 2. There we go, that makes more sense. So then what do I have here? This is a 2 rad 2 plus a 2 rad 2, so that's really a 4 rad 2 over 2. Now can I reduce these outside numbers? And so then I get 2 rad 2. Careful with your negative signs, that could mess you up. Your final answer should be positive 2 rad 2. It's positive, does that make sense in our picture? There's more of our graph above the x-axis than below. No, it looks pretty equal, but more of our graph looks like it should be above than below. Okay? All right, anytime I'm trying to do area in between two curves, make sure you're integrating it. Find your intersection points, and then integrate your top function minus your bottom function. Okay? We're not always going to have only one intersection. Sometimes they might intersect a couple different times. What do you think would happen then if we intersect a bunch of different times? We'll talk about that at a later date. Your homework tonight is 7-1A, page 452. You're doing 17 through 25 odd, number 45, number 47, number 65, and number 66. Behave yourselves. I'll see you tomorrow.